I believe they're coming from all over the world, so this is why we're doing it at 2 p.m. UK time. I'm in the middle of the world, Middle Earth.
Yes, 2 p.m. It's 2 p.m. It's okay.
In the Dales, actually. I'm almost like one of the hobbits where I live. So now I can see myself. That's fine. Last time I couldn't. I've got so.
Because last time you were not sharing your screen. You were just doing your PowerPoint.
No. I mean, last time we did the trial run, I couldn't see myself. I think I was the host.
Just really, next time, look at the webinar option. It's a little more expensive, but if you want to do something like this, it's really the format that works the best. Okay.
So how many people we got now? Do we have enough, or we scheduled another minute before the start? I'm fine. I can wait a few minutes for people to catch up, but it's getting late in China, getting late in Vietnam.
I mean, it was scheduled at 8, so no, I organize my time.
Yes, good to see you. Good to see you again.
Good to see you.
Hopefully, when all this dies down and we can travel again, I'll be coming out your way.
Know, I had orthodontists from Switzerland who started to be interested by your technique because economic crisis, they start to look at, even in Switzerland, they are thinking, start to reducing the cost, and aligner and lingual in-house is really, you can really crunch the.
This is one of the things that sprung to light with this crisis that's going on in the world at the moment, and we don't know really enough about it, the actual virus, to predict what's going to happen. But people are adapting; they're learning to adapt. As you said, there's more Zoom meetings. Zoom has really sprang to life. And Microsoft Teams and stuff like that. People are realizing.
You see also the beauty of
work
this
from home. You know,
even when the crisis is finished, like this kind of things. Why we did not do this before?
Well, this is it. I've been getting quite a few inquiries via Facebook as people realize that, well, maybe I need control over my work. I need control over my lab work as well. A doctor yesterday said to me, he's predicting that he'll have more lingual to do rather than aligners, because if the crisis has affected people's pockets, then we need to find an economical solution for the patients. And one, rather than going to one of the big companies like Invisalign that charge a lot of money, or 3M for the lingual, for like incognito, etc. People will be looking for more economical options. And in doing it in-house, you can control the cost to the patient.
It's not only the total cost. It's something very basic. Like we have Christian Sanchez in the member. The thing is, when you do your lab, you don't need to ask for a big deposit at the beginning. Contrary to working with incognito. Incognito, I knew that, my experience, even with patients who can pay. When you tell them, oh, but the first payment, we need 3,000, so they start to think. Whereas when you can tell them the first payment, $500 just to cover the lab cost, it's all of a sudden, it's become a lot smoother, a lot more smooth. So
Christian did a lot of work on that. He's very good on the business
on the
side.
Economic. But he didn't do it this way. He worked with banks. But the point is, he saw that the main reason why people were not doing lingual was the big initial deposit. It was really a killer issue. When you do your lab, all of a sudden, it's a lot easier to manage.
And also things like we've talked about this before. When you're doing it in house and you want to put a new bonding position for your bracket, you want to change your position, you can do that. You can do it quickly. You can do changes. Or if somebody loses a bracket, you can do a rebond quickly.
I time myself with your new device. I wanted to do this. I say how long I need to make a new prescription. Yeah, inside 5 minutes.
Yeah. Well, when I was in Vietnam, I showed them just a 3-to-3 2D bonding. I made the tray, and we did it all in 45 minutes. So they suddenly realized they could have patients from the provinces coming in the morning, take the impressions, and say, come back after your lunch, go and get a coffee, come back in a couple of hours, and they're bonded the same day before they go back to the province. So
Yes.
you can't do that with with systems where you have to send it out, you're waiting a long time. And also, as you know, it's the learning process. You learn a lot more when you do it yourself.
Oh yes, no, it's not that you do the lab, but how to say this? When you do the lab, you have to think to the mechanic. Like me, I remember first time you do the survey, you see, oh, this is the angulation. Then you do the survey of your setup. Then you can think, okay, it's an extraction case. Where do I put the compensation? How much? And after you see it play out in the mouth of the patient. So it's in fact it's exactly the same thing when you do a liner in house, because you design your movement and okay, I want to move this teeth, I want to put an attachment. Then you see how it plays out, and you can change on the fly, which is not really. I mean, incognito give you very good result, but you are trapped into the system. If you want to change something, it's when you have to order a new wire. It's not as smooth as okay, I change the prescription on this one. Or I change my arch form, because you can also change your arch form. It's a lot more, a lot more reactive. And me at my level, I saw it with 2D, because I had a lot of 2D case. When I saw when the case I was doing when I started, which was aligning for teeth in 1 year, to what I am doing now, the learning curve is really it's not it's faster. In fact, it's just that you can do so much more case because you control the cost. That's the thing. And also, you can make mistake. Okay, you know that if you make a mistake, well, you can redo the lab work. It's not the end of the world. You have to spend some time doing the work. But if you make some mistake with incognito, what do? You put braces in front. It can be difficult. So you have always this stress when you start a case with an appliance which is expensive, which is, will you be able to finish? Okay, and I would say it's psychological more than reality, but it's something. You ask $8,000, $6,000 for a treatment. You must be able to deliver. Okay, when you do in-house, when you can do in-house, all of a sudden you can start by treating the staff, the family. The initial cost is the cost of the device, which is not that much compared to an aesthetic appliance. And by doing you learn. I mean, I don't trust people who tell you do my course and you can do, because in my experience, you still have the learning phase. No, it's everything will go wrong on the first case, whatever they tell you. Even in Invisalign, you will have trouble. It's life.
Well, this is how Enrique describes it when he starts off his courses. As you know, being on the course, you don't have to really change your thinking if you know how to do labial. You know how to plan a case. You just start applying your labial knowledge directly to your lingual work. And there's just a few things that you need to look out for and need to be aware of, apart from that, it's your time and effort. Somebody's drawing on my screen.
Yeah, because everybody can draw on the screen, but you can. That's why I tell you next time do the webinar, because you will see they cannot do this. Okay.
Please don't draw on my screen. Somebody's just put a couple of blue lines.
If you go in option, no, me I cannot. So I suppose it's perhaps a kid doing this. But anyway, also what I saw is people who get trapped in their appliance, like they know how to use Invisalign and they don't want to switch because they think that their knowledge is dependent on the appliance they are using. Same thing with incognito. Or Win, or they get used to the appliance, and they are trapped. No, it's
You're
and
right.
they have the advantage of having done a lot of case, so the price is lower. So in fact, it's a kind of a sweet trap. Whereas when you do your lab, no, me, I wanted to try self-ligating. No trouble, I buy self-ligating bracket. Okay, and, oh, in fact, by the way, it's totally worth it. You can. And we don't have the dentist who only the last case, but she really liked the self-ligating a lot.
Yeah.
Okay, but if I don't like your bracket, I can. So that's the point. I can use whatever I want. So I can use what shape of wire I want. It's very versatile. And the strange things on the group Orthodontic Mastery, you had a presentation by Dr. Little about a new appliance where you can design the bracket, you can modify the bracket, you can even modify the shape of the wire. You can modify the slot, and I was, it looked a lot like In-tendo, but in CAD-CAM. And I had one orthodontist who spoke to me about the appliance, and I was, I thought, that was very interesting because that's the first time I saw a CAD-CAM solution which allow me close to the freedom I have with your appliance. And you know what she told me?
Mm.
Yeah, but it was looking very complicated.
Mm.
They don't want too much option. In fact, they want these things. Okay, I give you 2,000, and I want something. I just put in the mouth of the patient. I put the wire, and everything is done work like magic. Whereas, in fact, me, when I look at incognito, I am, but no, the mesiodistal length of the slot of the canine is still super small. Okay?
Hi, Christian.
Hi, Peter. How are you doing?
I'm good.
Sorry, I am kind of new in this new technology, so
I think there's a lot of people. Don't worry, it's a trial run. So
I can see some friends there, like Gilbert. Hello, Dr. Gilbert. How are you?
I can't see many people. I can only see 4 because I'm sharing my screen. So I've just got a limit up to 4 people at the moment. I can expand it, but it's quite difficult to then see my screen if I see everybody's face. Hi there, everybody. We're going to start, I think, because otherwise we're going to be very late. We are. So
I thought we have already started. I don't know.
No, well, we started, but I've not started my PowerPoint, if you like. So you'll know most of this stuff. Christian, it's a very brief, well, it's not that brief, but it's a basic introduction to various lab systems, a little bit of history here. And so if we're ready to go, are we ready to go, Jamie, or are you waiting for some more people? Hi, Jamie.
I think we can start. Yeah.
We can start. Okay. Hi there, everyone. This is all a little bit new. We're trying this Zoom meeting. Needs must in this day with this terrible crisis that's going on around the world. I hope you're all safe and well. And I'm sure there'll be more of this to go. I'm just having a discussion with Dr. Nicholas about how people are changing to their view on how they need to work. And this could be one of the things that will help you. You will develop, start thinking about doing more work, having more control over your work. So this intro to the lab system, which shows you that you could have complete control over your lab work as well, if you're willing to. And there's people on this meeting here that's already started that and very successfully. So I'll go ahead. First, some of you might have been following my In-tendo Facebook page. There's quite a few followers, 13,400. And so some of you will have seen the posts that I do on a regular basis when I have time, that share my ideas and share some of the things that I've been doing. But I'll just give you a brief introduction to me, who I am. So in 2004, I was invited to go to Dr. Fillion's lab in Paris. I think everybody who studies lingual orthodontics was done lingual orthodontics will know who Dr. Filion is. And we were invited there to buy the modified TARG and learn how to use it. I wasn't involved directly in orthodontics at that time. I was the production director of a large export laboratory in Thailand that I'd helped build up from 11 people when I started in 1998 to 300 people by the time I left in 2008. But, well, I thought, well, that's okay. 2 weeks in Paris, let's go. But what's lingual orthodontics and who is Dr. Filion? As I said, I had already some career in the dental work. I've been a dental technician for 22 years, doing all sorts of work, but my knowledge of ortho was limited really to basic stuff that most technicians know, like the Hawley or the wraparound. But I was innovative during those years. I'd studied mechanical engineering before I started dental work. And here you can see I had a technique that was published. I actually got the cover of Dental Technologies magazine in 2003, edition number 60. So I was already thinking about what I do, always innovating, etc. So somebody's come up there. Well, I thought, okay, I've got a 12-hour flight. Maybe I can read up on the plane, because I was sent there quite quickly. And there was just one book at that time, really, that I knew I could find on lingual orthodontics. And lo and behold, inside, that was Rafi Romano's first book, Lingual Orthodontics. And chapter 18 was all about Dr. Filion's technique. So I read about that. So thank you, Rafi, for making that book. It was a great help. And I did a couple of meetings with Rafi before. We presented in Chiang Mai, in India, and in Bangkok. So that was the TARG that we bought. There was the modified TARG from Dr. Filion, and that was my first case. Obviously, a test case, I presume. They wouldn't have given me a normal case to do, but there we are. And you can see the instrument and the space that I had to work in. And this is a picture of one of Dr. Filion's technicians, probably his best technician there, was Jack, and he'd modified the way he worked. So I was quite happy that I'd taken this picture, because this picture spoke 1,000 words later, as I valued the technique and thought about the instruments that we were using, because he'd obviously changed the instrument, turned it around so that he could work faster and better, because of ergonomics, basically. But there is some error there in that photo that you can see is working from 2 different planes. So maybe that wasn't such a good idea, because when you're using instruments, precision is absolute. You need precision when you're talking about a slot, which is very small, a slot on an orthodontic bracket. The slightest bit of error will cause big errors in torque. Tip we can see to a certain degree with eye, but torque is very, very difficult. So on the left we have our modified TARG, and for me, that after about 3 days I realized that would equal this plus something else, which I wasn't sure of at that time, but I had already had this picture in my head through my engineering days, because this was very difficult. Here was a big mistake. You don't have calipers dangling off a DTI. That's a dial test indicator. A dial test indicator should not have any force, any weight on it. It's a very precise instrument that measures very small increments. So we started with some ideas, lots of prototypes. You can see we actually made prototypes here. We have different ones here and here. And we went ahead. So sometimes to change a system or a technique, new instruments are needed. It had been a 20-year gap, 1984 to 2004. And there have been some modifications made, but I thought that I could make something better and easier to use and more precise. So we did the BPD, or the bracket positioning device, first. And I had this idea actually 3 days after working in Dr. Fillion's lab the very first time. I just saw and I thought it needs a jig, it needs a linear slide, it needs a fine height control so that the jaws, the calipers don't move upwards while you're bonding the bracket, which they did in those days. It was very hard to control both thickness and the height at the same time. Quite tedious. So after about 3 months in the lab, we already had the drawings for the BPD. That's just me. So just an ordinary person. As I said, I'm not an orthodontist. I don't even consider myself an orthodontic technician in the traditional sense. I know a lot of very, very good orthodontic technicians who do wonderful appliances, mainly removable or semi-fixed. But I was the only one in the company who spoke French, so it's a little bit of a joke there. Je pense, donc je suis. I think, therefore I am. And we had an instrument very quickly. By December 2004, we'd made this instrument. It was not the final thing, which I have today. We had a big granite base that really wasn't needed, made it very heavy, but it worked, and it worked very well. So it was put into use immediately. When we put it into the lab, the technicians just used it immediately. They stripped everything off the targ except for the blades, and we would set the tip and torque with the old targ and then go to the BPD for bonding the brackets. Dr. Fillion visited 2004 with my two technicians, the first two that we trained, to do this technique. And at the same time, we talked about how we were going to get around the targ issue of the blades and the tip and the torque. And the idea was to create the first ever digital targ, which would measure, not only set like the targ blades do, like the slot machine blades do. You set the position of a model to a specific tip and torque following a prescription. But with this instrument, we could actually measure tip and torque. So we could actually measure malocclusion models, we could measure setup models, we could compare values, we could make our own prescription, and then use in reverse. So by October, nearly a year later, we had the first TAD. These are some of the problems that I saw with the targ. Now, the protractor up in the top left, it's not really a problem. As long as you can see, 1 degree in orthodontics, I think, is fine, because you can't work to any more precision than 1 degree. I'll just let everybody know that after a while I can stop and ask some questions. So I'll get to the end of a section and then we'll stop to see if anybody's got any questions before they forget what I was talking about in the earlier slides. But it was the imprecision of the instrument that got me, the way that it had been manufactured. There was play in this part of the instrument which controlled the torque blades, and you could easily change the torque 2, 3, 4 or 5 degrees, just the way that you tighten this knob, the screw that held it in position. So there was a lot of imprecision, and as I said, one of the biggest things was the calipers would ride up here as you were bonding, because the tooth is triangular, if you like, and we could talk of the lingual surface as the hypotenuse of the triangle, of a right angled triangle, if you like. Then as you bonded the bracket, it would ride up the surface of the tooth, ride up the hypotenuse, and it was very hard to control. And we did a lot of study. We just didn't make the instruments. We compared, we did cross-referencing. We bonded models with the TARG, the old TARG, and then we went back and we checked them with the new BBD and the TAD, and we found that there was quite a lot of error in between the two systems, which we put down to the inaccuracies of the manufacturing of the TARG. So here we have the first TAD, torque annihilation device, and yeah, between 3 and 10 degrees of error, depending on the user as well. Obviously, you can have user error. You have to learn how to use them properly. So by February, it was all finished. We'd finished our work, we'd finished our studies, and I was asked to present them at the first WSLO, well, show them on the trade stand there. So by Dr. Filion, so we went and we showed the instruments, which created a little bit of a fuss. There was a lot of interest, people coming to look to see what was new. And that's when I started to meet people in the lingual orthodontics world. And then Chiang Mai University approached me, and the head, Dr. Didawat, of the faculty there of the orthodontics, asked if he could do a paper with us where we measure a lot of models, a group of northern ties with good occlusion, and to find out what the values are following the same method, but obviously with better instruments, following the same method that Andrews, Beckett, Hilgers, etc. had used. And then we would compare those values with northern ties with good occlusion. You can find that article online. It's on my websites as well to be downloaded. And that was accepted in WJO. There it is. Crown angulation and incolation of northern ties with good occlusion. You can read in the article what happened. And then you can start to think logically, well, you know, do different groups of people geographically need different prescriptions, and why are we restricted to a very small selection of prescriptions where the studies were mainly done on Caucasians, Western people, you know, faces change, tooth morphologies change, etc. And anybody who's worked in different places around the world will have seen this. I know Dr. Nicholas is here now in our group, and he now works in Vietnam. He worked in Cambodia before, and he did some studies in Thailand. So he's seen this as well, the difference between the Western side and the Eastern side. So 2006, 2007 was a very busy time, met a lot of people. This was second WSLO. There you've got Vittorio Cacchiofesti, Ian Hutchinson, Asif Chatu. You have Dirk Whiteman. I got a compliment on the instruments, which he thought was very good. Me and Rafi, that was in Pune, in India. And you see lots of other people here. And Dr. Scuso, who actually bought one of the torque angulation devices. And Dr. Filion incorporated them into his lab. So let's get on to indirect bonding systems for labial and lingual. And they vary somewhat. They offer various advantages with regards to either precision, ease of use. I've used to put a lot of writing into my PowerPoints because I realized that there's people from lots of different sides of the world. Maybe you have a problem with my language to understand me. So I've tried to include in the PowerPoints as much text as possible. So sorry if it looks a little bit boring, but at least you can read it and get a gist of what I'm trying to say. So you can do direct bonding for labial. I think a lot of people do. Even though indirect bonding is more precise, and we can go into that later. But for lingual, it's really difficult. I think just the act of bonding the brackets on the patient is very hard to see. You're working on the dark side, and to get the precision is very doubtful. The less time you spend preparing the work, in a laboratory situation or on the bench. It could be in your clinic. If you're doing 2D bonding, all you need is a small space. The more time you will spend clinically, the more time you spend preparing your work to get more precision on the model and make that transfer into the mouth, then the less time you will spend clinically. These are just some quotes here about indirect bonding. One here from Craig Andraco, designed insignia for Ormco. Bit of a genius, Craig Andraco, making that system. But, it was all about indirect bonding, and that it's more, you can find these quotes online, you can go and see them, that he explains, that indirect bonding is a lot more precise, and that's for labial. So you think about it on the lingual side, it's a must. Here from MBT, 2001, McLaughlin, Bennett and Trevisi, you have them saying the acceptance within the orthodontic speciality that accuracy of bracket position is vital to the success in modern orthodontics. Indirect bonding is more accurate. They make that statement. The technique reduces the amount of chair time. That's one big plus. In big clinics where you have like commercial clinics with lots of chairs, obviously the orthodontist is not bonding the brackets if it's indirect. They leave it to assistants. They're bonding the brackets, and everything's been pre-planned. So it does save a lot of time. Although the early days, which we can go into later, of indirect bonding wasn't that much more accurate for the bracket positioning. It was mainly for speed, because they were still bonding the brackets by hand onto the model. For example, the more closely the appliance matches the orthodontist as well, the less work is required in finishing. So it matches his way of working, his style, his philosophy. And they state torque control is the weakness of the pre-adjusted appliance. In any system which is based on edgewise bracket, there are 3 factors, and because of these, there does not seem to be a set of torque values that solve the need for all patients. And that's telling you that they knew they designed a system, MBT, but they knew that the weakness was torque, and they knew that really there wasn't one prescription that would suit all patients. Other studies, there's been lots of studies. I mean, you have to go and search. If you're interested and you want to learn more, you have to go and search on the internet. You can find it all. You have to read articles. I've spent thousands of hours reading articles, reading all the books that the orthodontists use. I'm here in my room, I have a big shelf full of books. And because the more I can understand about how the dentist or the orthodontist is working, the better I can understand to do my lab work, because doing fixed orthodontics is different to doing removable orthodontics. And this was a good paper by Professor Earl Johnson. It was given by a friend to look at in 2013, but I'd already been talking about this for years. So in 2010, we started the IN-tendo system, which was a lab system based around our instruments. But this is a good article, and he basically talks about torque loss and how much you should think about to compensate. I mean, it's quite basic because you've got other factors that I'm sure you'd appreciate, in direction of the forces, when you're doing retraction forces, etc. You'd have compensation the other way. But it's still very interesting to read. So what type of bonding should we use? 2D or 3D? Well, the choice is yours, and the choice depends on the cases. Some doctors will tell me they don't want to do any 2D. Some doctors have the facility to do 3D and do it quickly, and they'll do it themselves. Other doctors will want to do a mix, and if a case is quite simple and they don't have to worry too much about torque control, then they will use 3D for various 2D, for various reasons. Some of the brackets are flatter in 2D bonding. You have the Forrester dent bracket, which is more comfortable for the patient. But I've done a PowerPoint that we were talking with DTC about sharing. I've done a video as well of doing the actual 2D bonding. It's very easy to do. You can see from these images here. I'm going to just show you a few slides of my 2D. Obviously, it's another subject, so the whole PowerPoint is step by step. But this was one of the slides here using the gauges that DTC now make for me. The IN-tendo 2D gauge, which I invented myself, and it stretches across the teeth so that you can get both cusps. You can get across to the buccal cusp, which you can't with the boom gauge. And you can check the slot height, or you can create a slot position on the model by scribing on the model and then follow the slot line. Because if you follow, this is another one, if you follow the top of the bracket, in some systems, the distance from the top of the bracket base to the slot varies within the same system. So if you're placing all the brackets at the same height based on your bracket base, your slot height will change. In some systems, it can change about 1 millimeter. So you have to think about this. So that's why I like to visualize a slot line when I'm doing the 2D and mark it on the model. And that's the line that I'm going to bond my brackets to. But you don't need much special equipment to do 2D bonding. It can be very quick. Recently, while I was in Vietnam, I bonded a 3-to-3 in their clinic for them on a model, and we made a transfer tray, and everything was done in 45 minutes. So that meant that they could have a patient in the morning, take the impressions, tell the patient go away for lunch, come back in the afternoon and bond. Especially if the patient was traveling any distance. But 2D bonding should be done with indirect bonding as well. I mean, all bonding by hand is 2D. Even if you're bonding directly on the labial surface of the tooth, you're still really only bonding 2D. You don't have the precision of 3D. Even though you're using pre-programmed brackets, it depends on where you bond that bracket on the tooth as to what torque it will give you. So you're losing the torque aspect, the accuracy of it. So step one, these are some of my slides. You prepare all the elements and the tools needed. The right tools are important. You need some pliers. You might need to bend the brackets a little bit. You might need to bend the hooks. And when you do, you have to check the slot. So you need a wire, piece of 1825 stainless wire that you can slide through the slot to make sure that the slot hasn't changed. Some brackets are softer materials than other brackets. Some are easier to bend, manipulate, and some are too soft maybe, so that when you do manipulate one part of the bracket, it affects another part. But you can prepare the brackets also by microblasting, which increases the retention of the resin to the bracket. And I think the companies now are offering this as well. But I do believe we were probably one of the first that did that. I didn't know anybody that did that, and it came out of necessity. I won't go into the story, but we did it in 2005. The first time we were microblasting the brackets with 110 microns to etch the base and give us a better adhesion to the composite. So I'll show all these details in a step-by-step. There's another step 5. I've jumped a bit, blocking out the models, the important steps you need to do, marking the axis lines. Now, this is one of the challenges in any lab work, is getting the axis line correct. Because if the axis line is not correct, then you won't, your bonding will be off, and then it will throw everything else off. So it is one of the most challenging things, is actually getting a good long axis of the clinical crown. Now, keep that in mind. It's LACC, the long axis of the clinical crown. It's not the axis of the crown and the root combined. What the patient is seeing above the gum line and what you want to align is the crown. So that's what we're concerned with when we're bonding the brackets. Although we do, you can see on the slide there, we do ask for panoramics and x-rays so that we can look at if there's any particular problem with the roots and make some slight compensations where you might have roots that go off at an angle and then would be merging very close to another. But a lot of doctors have told me they don't really bother. It's not important. And here you can see putting some separator on the model, etc., and blocking out the model. There's various reasons for that. I found some very nice pliers, tweezers, sorry, for putting the brackets on. And they're from a DIY shop. They're nothing to do with orthodontics, from a company called Yato. And they're perfect for holding the brackets behind the wing, between the wings and the base. And I can see very nicely when I'm positioning the brackets. We developed a technique because we started microblasting the brackets. We realized that we're handling the brackets a lot more. So now you need a system of cleaning the bracket before you bond. So I think we were also the first to do that in 2004 by using acetone to clean the brackets. So I have different microbrushes here. I clean it with acetone. I give a good scrub immediately before bonding. This is after the trial, after trial positioning, testing the position, and then I will put some transbond primer on, just a tiny bit to dampen it before I bond the transbond on. Transbond is very good for that. This is, you can see a close-up positioning the bracket on the model. And for anteriors, you need to incorporate some tip. And we'll come back to that. I'm going to talk about the brackets in a minute, why we have to do that. Hello. There's some people talking in the background. If you have any questions, I can stop. And after this slide, we're going to stop on this slide, and anybody who's got any questions can ask me. This is just a slide showing you how you visualize tip. This is the upper right central, the number 11. That's negative tip. The hook goes away from the midline. This is the midline. And when you have positive tip, hook goes towards the midline. Hello? Somebody's talking. Can you switch your microphone off?
Somebody is interrupting.
Unless you want to ask a question. Any questions from anyone? We're going to come into the bit now while we're talking about between 2D and 3D. There's just some examples of 2D bonding. With the Forrester Den brackets, you can see I mark the base because every bracket is the same. The distance of the slot to the top of the base is the same. And the slot, well, it's not really a slot. Where the wire goes is at the top. So we would use that as the reference line. But you can see that they're following pre-programmed tip that I've programmed by positioning on the model. So what you just saw in the previous slide, I'm drawing the tip that I need to put in because you're doing it by hand, so it's all visual. So this is like you would with your direct bonding in the mouth. You're just estimating the tip. I mean, you can measure it to a certain extent with protractors, etc. It's not easy. So you need some experience. And here you can see at the bottom we have some crowding. And with the crowding here, you've got the brackets, and we're still able to bond them. So Lab time, clinical time. Lab time, clinical time. It's your choice. What do you want to do? Spend more time on the bench preparing things, trying to get them to a level of understanding that you can predict a more predictable outcome in the clinic, and then you will spend less chair time. That's another close-up from a different angle so you can see how flat the brackets are on the teeth and the various morphologies of the teeth. So here's a case from Dr. Nicholas, who's with us today, a 2D case, and he offers his options to his patients, ranging from lingual to aligners, and he does all of the lab work himself at very little cost. He uses the IN-tendo instruments for his 3D work and a CAD program for aligners, and with 3D printing, and he controls all of it himself, and he teaches his dentists and his orthodontists where he's working how to do it themselves as well. So he can judge what type of case he can work with 2D, what type of case he wants with 3D.
It's my first case you are showing.
But yeah, I mean, the outcome you can see, you know, it's another case. But there's something to think about here as well. While he's got to this stage, he's bonding his brackets on there, he's mastering his wire bending and his auxiliaries and how he applies his forces. We have to think in lingual about this.
Just to be clear about 2D, not to give false impression, except very specific case, is 2D does not work if you cannot finish with a liner, meaning you have to do a liner in-house, or the cost of the lab for the aligner make this option not worthwhile. You are better off doing 3D right away. Because 2D without doing 2D without doing a liner, it's a nightmare, because the bracket, I mean, the bending is complicated because the slot, you know, the slot have no precision at all. You deform the bracket each time. So just be clear for 2D. If you want any precision only by fixed appliance, it's 3D. We have to be clear about this.
Yeah, thank you. That's a very important point there. And it's the mastery of the technique as well, which is very important. And I've always said in my seminars, and some of the people here today have done one-on-one courses with me. They've been on group courses with me and Dr. Enrique. And I always state at the beginning of the course, the lab work is not everything. The lab work is maybe 50% of the work. Some people say, no, it's more. But it's just to let you know that it's also how you control the case clinically, and the clinical aspect, the mastery of the technique in the mouth is very important. You can't expect a system to do everything for you. And we're going to come on to that. But this is a very important point to think about before you even start bonding brackets in lingual. You have to look at the lingual surfaces of the teeth, and some teeth have these very enamel elevations, you know, very strong cingulum morphology. It's very difficult to place a bracket here. And just one elevation like this could mean that you put in a lot of composite on the other teeth in 3D bonding. So that means that the brackets come more into the oral cavity and make it more uncomfortable for the patient. And the further the bracket is away from the tooth, the less biomechanical control you have over that tooth. We'll come back to that later, but this is just something to think about, that you need to do some preparation before you take your final impression for sending to the lab or doing the lab work yourself. And there are photos from a different angle, and you can see here also blows in the model, a couple of air blows that we would block out with the block out wax, and we would over block out because otherwise, you know, the tray would rot in the mouth. So when it comes to working with the lab as well, the correct information and communication to the lab is really important. if we want a successful bonding. This information should include future planning, any prosthetic or cosmetic work in collaboration with prosthodontists, future crowns, tooth reductions, changes of morphology. For example, if we've got a tooth that you're gonna restore with composite, we don't want to level that tooth because we're measuring from the incisor ledge. So if you've got a worn incisor ledge you want to restore with composite, we want to keep that tooth in the same position. So the bonding height for the bracket will change, and vice versa. If you're going to do a reduction of say 0.5 millimeter of the incisor ledge afterwards to make the tooth look better, to more aesthetic, then we should bond the bracket 0.5 millimeter further down than the tooth adjacent to it, so that you'll be able to trim that tooth afterwards. I mean, there's lots of little things that we have to think about, and you have to communicate this, because obviously the lab aren't mind readers, and they can't say what you're going to do with your case as you go along. So you have to plan your case properly, and all these eventualities need to be thought out. As I say, x-rays are very important. I ask for photos, x-rays, everything. I like side profile photos, full facial photo, close-up of the smile so I can look at midlines. And I know technicians, and I've recently found out, which is, disturbed me a little bit, technicians who are doing aligners and stuff, and they're doing setups on a computer because it looks easy on the computer to move these teeth around. I don't actually think it's that easy on the computer to move the teeth around compared to doing it manually, because you have you're working through a 2D medium, a screen, which is 2D, to do 3D movements. I think you should have virtual goggles for this type of work if you're going to do it 3D. But I've done some on a screen, and I've done a lot manually, and I realized that some people are doing their setups just from a digital scan. They have no photos of the patient, they have no x-rays of the patient. I mean, how they can judge about where the midline is, or they have very little information on the lab forms. They're just given scans and said, align the teeth, level the teeth. Well, unfortunately, that's not how it works, and that's how you get into a lot of error. You need a lot of communication between the lab, and anybody who's worked with me will be tired of my emails asking for that information if they don't give it to me. So it's a very important aspect.
Just one point, because that's something that I wanted to speak about, and I will send you a document if you want. If you just look at the scan, you cannot be sure of the position of the root.
Yeah.
Okay. And I had the 3 cases last week and 1 more today, where I have my virtual root on the setup, and when I look at the panoramic or CBCT, the roots are off by something like 10 degrees. So you understand that if you want to do something like a rotation and you think you are in the axis and the root in fact is like this, with a liner it will not work, and with fixed appliance you will have some issue. And today we had a patient who have done outside aggressive stripping with a burr, and in fact you think the crown is like this on the scan, you look at the panoramic and you realize that in fact the real crown was more like this, and it was, they changed the shape of the crown when they did the stripping with the burr. And that's something, if you don't have the X-ray, you will miss it, and you will have mechanical trouble, because you apply the force on the crown, but you move the roots.
Yes.
And if you don't have, and if you don't have the picture, what I tell them when they send me a case without at least a smiling picture, how do I know if I have to intrude the lower or the upper?
Yeah.
And there's a difference between a smile and a great smile, and it's not because I make a fixation on documentation. I'm using the documentation when I do the setup.
Yeah. No, it's very important. Thank you. It's really important. As I say, people who've worked with me will understand And there you are, Nicholas, at our lab. Remember that. And Nicholas did work with, before coming to my lab, he wasn't new to Lingual. He'd been working with Incognito and Win, and was one of the few registered providers in Southeast Asia for doing that. So it's this is another case, but this is 2D bonding, you see, with a 3D bracket. You can use any bracket for 2D bonding as long as you put a round wire in. But if you use a 2D bracket, you can't really change it to a 3D case. You could bond, and this is how Rafi Romano is explaining how he does his work now. He bonds very quickly in the clinic